let us start our lesson today. And today, inshallah, we'll be speaking about a new lesson, which is lesson 17. It's about the periodic table. Okay, so first thing I want you to learn about periodic table is why do we need to have a periodic table? Now, of course, you guys have seen the periodic table before and you know lots of information about it, but you should know that the first person who decided to make a periodic table, his name is Mendeleev. And Mendeleev is a Russian scientist who decided to organize the elements in one table. So at his time, at Mendeleev's time, scientists knew lots of elements, but they were not organized. So he said that why don't you organize all these elements in one table that he called the periodic table. Now, when Mendeleev organized his periodic table, he organized it on three bases. One of them is the mass number, the second one is the physical properties, and the third one is the chemical property. Okay, so I have now three criteria. I have the mass number, the physical properties, and the chemical properties. Now, if you guys remember from your previous studies, if you think about the periodic table, like if you open your textbook on page 500, you will see the periodic table, and you will notice that this periodic table is based on the atomic number. So you can see if you go from one element to another, you will see that the atomic number keeps increasing 1, 2, 3, 4, 5, 6, and so on. So you can see from left to right, I go 1, 2, 3, 4, 5, 6, and so on. So this one is based on the atomic number. But at the time of Mendeleev, it was not based on the atomic number, but it was based on the mass number. Now, if you remember, we have, for example, carbon 612. So the atomic number is 6 and the mass number is 12, right? So Mendeleev did not use the atomic number, but he used the mass number. Now, the other thing he did is he talked about the physical and the chemical properties. So what does physical properties mean? It means shape, size, color, melting point, freezing point, ability to conduct heat and electricity, and so on. And what does chemical properties mean? It means how the element could chemically react with other elements. So based on these three criteria, Mendeleev organized his periodic table. So if I go again to the periodic table on page 500 in your textbook, for example, if I look, for example, at the column number 11 here, you can see we have copper, we have silver, and we have gold, right? You see copper, silver, and gold. Now all these elements are together at the same part of the periodic table, and why is that? Because all of them are metals, all of them are shiny, and all of them are good conductors of heat and electricity, right? So that's why we put them together in the same part or at the same part of the periodic table. So that's how Mendeleev organized his periodic table. As I told you, based on the mass number, based on the physical and chemical properties. But the periodic table we have today is not based on the mass number. It's based on the atomic number. And that was not Mendeleev's idea, but it was Moseley's idea. So there's another scientist, his name is Moseley, and he is the one who is the one that came up with the idea of making the periodic table in terms of the atomic number. Well, you don't really need to memorize the periodic table. Don't memorize any element. Don't memorize any rows or columns, right? Because usually, if you have a quiz or a test, we provide you or allow you to access those elements in a periodic table. Don't do too much memorization. Like memorization is not good anyway. Okay. Now I want to go back to this nice picture of the periodic table. And I would like you to look at the elements, and I want you to look at the atomic numbers as you go from left to right. Now, as you go from left to right, you will notice that the atomic number is keep increasing, right? So you see hydrogen 1, helium 2, lithium 3, barium 4, boron 5, carbon 6, and so on. So if I go from left to right, you can see that the atomic number is keep increasing. Now, does the same thing also true, or is the same thing true with the mass number? Well, let's check. So if you check the mass number of the hydrogen, for example, then you will see that hydrogen is 1.008 and helium is 4.003. So it's increasing, right? And it keeps increasing like this, lithium 6, beryllium 9, and so on. But let's check carefully. If you go to the chlorine 35.4, chlorine is here 35.4, after that you will find argon 39.9. After the argon you will find the potassium, which is 39.0. So the argon 39.9, but the potassium is 39.0. So it looks like the mass number here is decreasing. So what is the rule here is the atomic number increases all the time if you go from left to right in the periodic table. But the mass number, it increases most of the time, but sometimes it does not increase and it decreases in some few situations. Okay, so now we have learned about the periodic table and why do we need to have it and so on. Now there is something happened to Mendeleev which was very interesting. Now when Mendeleev tried to organize the elements this way, he found some empty spots in the periodic table. So after he organized all the elements based on their mass number, physical and chemical properties, he found some gaps, some empty spaces in the periodic table. And then he said that there must be element that is not discovered, or it was not discovered at his time. And then other scientists tried to discover those elements, and they found all those elements by now. So here's the idea. Now let's say that you are you have a group of students, and someone told you that those group of students are all, for example, from India, and there's one missing student. And they ask you to try to think about the characteristics or the shape of this or the characters of the student. Now, if you know that all the students are from India, then you will never say that this missing student has green eyes or blonde hair, right? It must be something close to the Indian people, right? So the same thing happened to Mendeleev, that he grouped the elements together, and then there's a missing element. So he tried to predict the properties of this missing element based on the elements that are surrounding that element. You understand the idea? Okay, so for example, at his time, germanium was not known, and he predicted the properties of germanium based on its neighbors. In the periodic table, and he was very close to the right properties that we know nowadays. Okay, there is a question says that how did Mendeleev calculate the masses of the elements? Now remember that like at his time there was like some instruments that are able to calculate the mass number and the atomic number of the elements, like the number of protons and the number of neutrons. Like for example, there was different experiments that were able to tell us how much charge is there in the atom and how many electrons are there in certain elements. So at that time, scientists were very interested to calculate how many electrons are there, which is giving us the atomic number, and then by the mass of a specimen or a sample of the atom, you can also tell the mass of each atom. Besides, as you guys mentioned about isotopes and so on. Okay, now I wanted to check this periodic table, and I wanted to check any box. For example, we have this hydrogen box. Now for the hydrogen, as you can see, if I look at the box here, I will see the English name, which is hydrogen. I see the chemical symbol, which is H. I see the atomic number, which is 1, and I see the mass number, which is 1.008, right? So you see, so from this I can have most of the properties about the element hydrogen. Now let me ask you this question. Now all of us know that hydrogen is H1, right? So why here in the periodic table is not written, the mass number is not 1, it's 1.008. Who can say why it's 1.008, not 1? Anybody can tell? Yes, very good, excellent. Yeah, it is because of the isotope. So what does it mean? Now, if you guys remember in the last class, we have mentioned that the hydrogen has 3 different isotopes of what we call them. We call them the protium, the deuterium, and the tritium, right? And this mass that you see, which is 1.008, is actually the average atomic mass of all these 3 isotopes, right? So these isotopes of hydrogen exist, but they are not existing at the same ratio, right? So if you watch the last lecture about how to calculate the average atomic mass, you can see that this number in the periodic table is the average of all isotopes. Now you can see the same thing is repeated for other elements. For example, lithium 3.7, but you see in the table is written as 6.941. And again, that's because of the isotopes of the lithium and so on. Okay, now if you look here, you'll find also the periodic table can tell you the state of matter. So you can see the matter could be in a gas state, liquid state, solid state, or synthetic. Now what does synthetic mean? It means it's a man-made. It means that this element is made up in a lab. Because we know that elements can be either found in nature, like gold, silver, iron, and so on, and some of them are man-made. So we do them in labs, and we call them synthetic. Usually those synthetic elements are not stable, they're radioactive, and they change into other elements very, very fast. Now look at the periodic table, and you will see 3 colors in this periodic table. And we see blue, and we see green, and we see yellow. So we see blue, green, and yellow. Now the blue part of the table is what we call the metals. And the yellow part, or the orange part, is called the non-metals. And the part in between, which is the green part, this is the what we call the metalloids. So metalloids are having some properties from metals and some properties from non-metals. That's why they exist in between. So you can imagine, like for example, this the blue part, let's say that this is United States, and this is Mexico, and this is the people who are living in between United States and Mexico. So maybe they are traveling here, traveling there, they married from here, they married from there. So these people who are at the borders between the United States and Mexico, those are having properties from here and properties from there. So that's what we call them, the metalloids. Now I want you please to look at these 2 elements. One of them is called germanium, the other one is called the arsenic. So this is the germanium, this is the arsenic. Now can you guys tell me if germanium could have more metal properties or more non-metal properties? Which one is true? Metal, yes, very good. So the germanium should have more metal properties. And why is that? It's because the germanium is closer to the metals than to the non-metals. That's why it has more metal properties than the non-metal. You see, so that's how Mendeleev organized his periodic table. And if you look at the gray part of the table, this is representing the synthetic element that we mentioned, and you can see all of them are radioactive and so on. Now, of course, what you see now is an old version of the periodic table, but if you look at the newer versions at the internet, and you will find that there are no more gaps. Like all these elements are now known to us, and we know all those elements. Now, just last one thing to mention here, that here we have something called the lanthanides and something called the actinides, and those are part of the table here. So the lanthanides are after the lanthanium, and the actinides are after the actinium. Now, the periodic table has 7 rows and has 18 columns. I have 7 rows and 18 columns. Now I call the rows, I call them periods, and I call the columns, I call them groups or families, okay? So I have 7 periods and I have 18 families in the periodic table. Okay, so now let's talk about another topic, which is the energy levels. Now, of course, you guys have seen this so many times before, and it tells you that if you look at an atom, you have a nucleus in the middle, then you have energy levels that are surrounding this nucleus. Now, these energy levels are having numbers, so I have n equals to 1, n equals to 2, n equals to 3, n equals to 4, and so on, right? So you can see those energy levels here. Now, the question is, how many electrons can be accommodated in each energy level? What does that accommodate mean? It means how many electrons you can put in each energy level. Now the first energy level can take up to 2 electrons, the second energy level can take up to 8 electrons, the third one can take up to 18 electrons, and number 4 can take up to 32 electrons. So it's a 2, 8, 18, and 32. Okay, now there's if you forget this for any reason, you can always remember this formula that says 2n squared. So it's a 2n squared where n is the orbit or the energy level number. So if I want to know what is the maximum number of electrons at the first energy level, then just put n equals to 1, so it becomes 2. The second energy level becomes 8, the one becomes 18, and then if I put 4, so 4 squared is 16 times 2, that would be 32 electrons. Okay, perfect. Now, you must understand that energy level number 3 is having 18 electrons, but if it has 8 electrons, it will be happy, it will be stable. And energy level number 4, it can take up to 32 electrons, but if it has again 8 or 18, it becomes stable. Now, as you move away from the atom, then the energy increases, and as you move towards the atom, the energy decreases. So if I go to the energy level number 4, then energy will be higher than if you are at energy level number 1. Okay. Now our next topic is to know about the periods and about the groups of the periodic table. Now if you guys remember, I told you that in a periodic table on page 500 that we have 7 periods, that means 7 rows, and we have 18 families or 18 groups. The question is, why, for example, we put hydrogen and helium in the first group, and why we put lithium, beryllium, boron, carbon, and so on in the second period, and so on. Why Mendeleev is using this kind of organization? Now, is this something done just by randomly, or there's a reason that we put? Yes, exactly. There's a reason we put this kind of organization. Now, let me ask you this question. Who can tell me what, if you have a hydrogen atom, what is the total number of electrons that a hydrogen atom could have? Maximum number of electrons that a hydrogen atom could have? 1. Yes. So if you have 1 electron, yes, exactly, very good, guys. So if you have 1 electron, then the other question is, how many energy levels are needed to accommodate this 1 electron? To take this 1 electron, it's only 1. Yes, very good. Okay, it's only 1 electron, 1 orbit, right? So that's why hydrogen exists or lives in the period number 1. So what about the helium? Now let's think about the helium. If I ask you how many electrons, the total number of electrons that exist in helium, and it's 2 electrons, right? And then how many orbits are needed to accommodate those 2 electrons? Again, it is only 1. Yes, very good. So because the first energy level can take up to 2 electrons. So that's why hydrogen and helium live in the energy level in the period number 1 in the periodic table. So what about we talk about the lithium? Now lithium has 3 electrons. So 3 electrons means what? It means we have 2 at the first orbit and 1 at the second orbit. So I need 2 orbits in this case. That's why lithium is in the period number 2 in the periodic table. What about the beryllium? Beryllium is 4, so it's a 2 and 2, right? So that's why I need 2 orbits as well. So what about the neon? Neon has 10 electrons, so it's a 2 in the first orbit and 8 in the second orbit. That would be 10, right? That would be 10. So again, I need only 2 orbits. That's why neon also exists in the second period in the periodic table and so on. Now finally, let's try the sodium. Sodium is 11, so it's a 281. That's why I need 3 energy levels to accommodate the sodium, and so on for magnesium and so on, right? So now we got why elements are organized in those periods in the periodic table. Now let me ask you this question. Now hydrogen and helium, they both have 1 or 2 electrons, so hydrogen has 1, helium has 2, and they are both existing in the first period. So the question is, why do we put hydrogen at the beginning of the table at column number 1, but we put helium at the last one at column number 18? Why we don't just put them close to each other? Because they both need 1 electron. Yes, very, very good, Mary. Yes, because it's not all about the atomic number. It's also about the other properties. So we said we have also to speak about chemical and physical properties. And helium is a noble gas, right? So it should also stay with other noble gases like neon, argon, xenon, and so on. That's why we put the helium at the last column of the periodic table. Okay. Now we can move on and we talk about the groups of the periodic table. And as we mentioned that we have, how many groups? We have 18 groups in this periodic table. Again, the question is why elements are in the first group, why other elements are in the second group, in the third group, and so on, right? So now let's take the first group as an example. So the first group has what? It has hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, and so on, right? So why these elements are together? Why they are together? Now you have to think about you and your family. And do you share something? Now remember that you and your father, your mother, your brothers, your sister, we call you a family, but it does not mean that you are similar. You are not similar, but you share certain properties, right? Maybe you have maybe the same skin color. Maybe you talk the same way. Maybe you eat the same way. Maybe you believe the same way, and so on, right? So you have properties, not similar, but you are you share certain properties together, right? Okay, so those elements should also share some certain properties together. So this is the first thing. Now the second thing is about how many electrons are there at the outermost energy level. Okay, so what does the word outermost energy level is? It means the last energy level in the orbit. So let's talk about hydrogen. Hydrogen is having only 1 electron in total. So if I ask you how many electrons are there at the outermost energy level of hydrogen, it would be only 1, right? Because 1 is the only electron that exists there. So let's talk about lithium. Lithium is what? Lithium is 3. So 2 at the first orbit and then 1 at the second orbit. So if I ask you how many electrons are there at the outermost energy level of the lithium, it will be 1, you see? So what about the sodium? Sodium is 11, 2, 8, 1, so it's also 1. And so on for the potassium, rubidium, cesium, francium, and so on. So it means that all atoms of the group number 1 are having 1 electron at their outermost energy level. Okay, so now let's see if the same thing is true for the group number 2. So let me try with the beryllium. Beryllium is 4. So 4 means what? Means 2 and 2, right? 2 in the first energy level and 2 at the second energy level. So how many electrons are there at the outermost energy level? It will be 2. So what about if I speak about the magnesium? Magnesium is what? Magnesium is 12. So it's a 2, 8, 2, right? So also you have 2 electrons at the outermost energy level and so on. So the rule is this. All elements in period number 1 are having 1 electron at the outermost energy level. All electrons at the period number 2, at the group number 2 are having 2 electrons at the outermost energy level. Now, does this rule apply to all elements in the periodic table? And the answer is no. It applies only on groups 1, 2, 13 through 18. So 1, 2, 13 through 18. 1, 2, 13 through 18. So does that mean that the elements at group number 13 are having 13 electrons at the outermost shell? And the answer is no. No, they don't have 13. But they have how many? Do you know? The group number 13 have how many electrons at the outermost? Group number 13. Yes, very good. You should have 3, right? And group number 14, you will have 4. Group number 15, you should have 5. Group 16, you should have 6, and so on, and so on, right? So again, this rule applies to elements in group 1, 2, 13 through 18. Now, this takes us to a definition of something called the dot diagram, or electron dot diagram. So you can see here at this picture that we have those elements of group number 1, and each one has 1 dot at the top. Now, what does this 1 dot mean? It means the number of electrons at the outermost orbit. So what does that mean? That hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium are all having 1 electron at their outermost orbit. You see the idea? So if you check this picture here about the chlorine. Now chlorine is 1735. So the atomic number is 17 and the mass number is 35. So if you think about 17, if you want to distribute them, it becomes 2, 8, 7. So it means that the chlorine has 7 electrons at the outermost orbit. So you can see here we have 7 dots at the outermost. What about the neon? Neon is 18, so it's a 2, 8, 8. That's why I see 8 dots. So you have to be careful here. So the number of dots here is representing what? Is representing how many electrons are there at the outermost shell or the outermost orbit. It does not represent the total number of electrons. It's just the number of electrons at the outermost orbit. Now let's think about this example of the sodium and the chlorine. Now we know that the sodium belongs to group number 1, so it should have only 1 electron at the outermost orbit. Now while the chlorine is having 7 electrons, 7 dots at the outermost orbit. So now let's think again about sodium is having 1 electron at the outermost orbit. That does not make the sodium stable. Why? Because it must be 2 electrons to be stable, right? So sodium needs to get rid of this 1 electron. While the chlorine has 7 at the outermost, and again it's not stable because it needs to be 8 to become stable. So look at this coincidence that the sodium wants to give away 1 electron and the chlorine wants to take 1 electron. That's why they become friends, and the sodium gives away 1 electron, the chlorine takes this 1 electron. Now the sodium, as you can see in the picture, will turn into a positive ion, while the chlorine turns into a negative ion. And then we know that the positive and negative love each other, so they attract and they make the sodium chloride. Okay? Now elements like neon, argon, xenon, which we call them the noble gases, they do not like to do this kind of reactions. And why is that? Because their outermost orbit is filled. They are satisfied. That's why we call them noble. They don't need to interact with anybody else, and they just they don't do any kind of these reactions. Okay. Now let me speak about the next topic, which is the elements in the universe. Now, it's very nice to know what is in the universe. Now, we live in this very humongous universe. It includes stars, galaxies, planets, and so on. And we want to know what is this universe made up of. So scientists are very curious to know what is the universe made up of. And when we check the universe, we found that the building blocks of this universe is hydrogen and helium. So more than 95% of this universe is made up of hydrogen and helium. Now look what happened. Now if you go at night to look at the stars, you'll find them very beautiful and they fill they fill the skies. But how these stars are created? Now, they all start from the hydrogen. So the idea is hydrogen atoms come together and they accumulate together like a cloud. And then they get bigger and bigger and bigger and bigger. Their mass increases, and then they fuse together. And what does fuse mean? It means that they connect together, and they turn into helium. So four hydrogen atoms connect together or fuse together, and they change into one helium. And when that happens, some energy will be released. And when it happens at a bigger scale, a star will be born, right? So now you have a baby star that we call a protostar. We call it a protostar. Then the star gets older, like our sun, and then more fusion will happen, which means that the more hydrogen will turn into helium. Not even that, but helium also will fuse into heavier elements like carbon, like gold, like silver, like iron. So through the star lifetime, all these elements will start to be produced. It starts from helium, and then it generates all these new elements by the lifetime of the star. Now, stars are like us. We born like babies, and then we grow up, we become youth, then we get old, and we die, right? Now the same thing happens with stars. They start as baby stars, then they get older, then they die. When stars die, sometimes they explode, we call them supernova, and sometimes they collapse, we call them black holes, and so on. And sometimes they expand, we call them red giants. But anyways, assume that a star dies by explosion. So the star contains all those elements that it produced during its million and million of years lifetime, then it explodes. So all these elements will now go into the universe. Now they travel all the way and then they come to us. Now think about yourself now. Think about what are you breathing. You are breathing oxygen, nitrogen, and so on. Now all these elements have been produced inside a star. Think about your body, the iron, the potassium, the calcium in your body. All these have been also produced inside a star. So there's a very famous saying that says we are sons of stars, and it doesn't mean that we are sons of Hollywood stars, but it means that the elements that make up our bodies was made up into stars. So here's the idea that this universe starts from hydrogen and helium, and the stars are the factors of this universe. The stars are the factors of this universe, and all the elements like the iron, the gold, whatever we see here on Earth have been produced at one point in a star. Okay? So hopefully in today's lesson you guys have learned about the periodic table and why it's important to learn about those elements. How are we able to, or how can we read this periodic table? We should know where are the metals, the non-metals, the metalloids, and we should know what does the word synthetic elements mean, means the man-made elements and so on. Okay, so in the next lesson I will also teach you how those elements can combine together to make compounds, and what are the conditions to make compounds. I'm sure you guys have read about that before, and it will be too much fun to learn about those elements. Now the last thing we learned in the lesson today, that all those elements in the periodic table, all those elements had been produced inside stars, which is very interesting for those of you who like to study astronomy, learn about stars and so on. So this is all for the for what we want to say today about this lecture number 17, and hopefully we'll be able to talk more about this very interesting topic.